development because um, all the stuff is oriented on solution of some specifically defined problems. Namely, on the slide 1 is presented kind of computer simulation about some problem. In this context, we should take some decisions, and these decisions will be very useful, and we would have some expected results, and these results is defined in some kind of expectation about new or very known problems in some area. So before starting making some decisions, we need to define subject domain of decision making. So we have key conceptions. First one is decision making. Second is subject domain. Of decision making. Subject domain of decision making. What it means? It means that in this area of intelligible DSS, we have some eligible DSS, decision support system. So we can talk about one side of the problem is namely decision making. Second side is intelligence that is beneath of this decision making, because any kind of decision making should have some basement, and this basement is constructed from subject domain as SD, subject domain knowledges, subject domain knowledge. That means the knowledge about the problems, about the solution sample, and so on. So in this way of decision making, we should provide some very specifically defined stages that is going to make evolution of decision-making routine, because it's not the question of just single stage. Yes, it's a question of multi-stage routines, and we need to make a lot of steps before we are getting to some results in this area. So we can form a definition. Definition is definition of the question: what is namely the decision support system? Many sources define it like DSS is an information system that support business activities or decision. Sorry, somebody knocking in. It's Ivan Tomchuk. Hello. Let's read from the start. The question is, I just have made it a short introduction. We have a slide. From the general point of view, what is DSS? It's what we are seeing is some picture, and in reality, in real life, is many pictures, many charts, diagrams, maybe live mode videos, and so on. And all this is helping tools or auxiliary means that should help us to single out some maybe some information, maybe to for getting closer to some new information. Yes, key conceptions. We have no class desk, so I write it in our eternal chat. Its idea is that every DSS it gives some results of DSS. These results is it can have many forms, many different art and different kind, but we can say for sure that this decision, yes, is it's about getting some new information. So here is a slide 2, and this slide shows us a simple most simple decision making. So we can stipulate a topic of our first lab. So I type in here, and after I will transfer it to our Telegram groups. So lab 1 will be about rules-based DSEs. That will be topic 1, lab 1. It's to create rules-based DSS by the means of tools at your discretion. What you have preference or experience to working with, it can be and it can suit any programming language, like C, C++, Java, Python, so on, C#. I suppose it would be such basic, very known tools like C, C++, Java, C#, Python. So I put here many dots. One again. What languages? C, C++. So C, C++, Java, C#, Python, and so on. So you will use programming tool that mostly fit your stack of programming stack, the developing way of development, and so on. So what is a rules-based DSS? It's like when you're starting to learn some language, programming language, your first program usually is named like hello world. It's like first word you say, first output your program gives, and so on. So in our case, just rules-based DSS. Rules-based DSS is like this hello world program. Hello world, namely, it means we have some. You must have some experience with this solution. So here is namely question about precise textbook. Yes, precise methodical guidance. It cannot, just simply cannot present all the possible languages, because as of today we have a very plenty of languages, and functional, imperative, and declarative, and so. So on this lab, it can be described in, 1,000 pages of methodical textbooks. So I guess we need to give you innuendos, introductions, and you'll find the way to the solution. Finally, the question of choosing Programming languages, it's not the question of matter. All the languages in this case would be equally preferable, because it's only tools for building a solution. So, new conception, new topic is a DSS solution. DSS solution, it's mean what kind of solution we would give to client. DSS is our main topic for all this course. Yeah, for all this course. DSS they should be understood like general direction, general outline in which we give some solution making, yes. And if we get back to the first slide, it's here we have a very complicated interface. Is a program upper part, but this interface is not quite independent. It's have a very tight business logic, and we can state that this business logic would be like this. What I mean? I mean that business logic of such case, it should give us an sample of decision making. Sample of decision making. What I mean? I mean that we need to find and some solutions about these ways of proceedings of getting final choice. So we can state that all the things about decision making, it's very similar, very eternally the same as generally understood programming logic. I guess you will agree that somebody cannot develop a complicated program when he or she doesn't understand the business logic. The business logic is how the thing is working. What kind of information exchange routines we have? Which way these routines gives a way to newly defined solution in which we usually does not have a same patterns. The conclusion that in DSS we don't have some universally unified pattern in which all this stuff can be based. Why? Because that is the nature of the data. Nature of the data. And working this way, we just one way or other way, we're getting closer to the simple programming logic. Simple programming logic. It's logic like operator if. Operator if is a key to understand what is all this about. What is about. So we are talking that if we have some conclusions fulfillment, then we can state some conditions. Some conditions is these simple brackets. There is condition, and it means that if this condition is true, then we have action. In general information solution and application, we have a notation that allows to put the logic behind the things. I guess in your bachelor degree you have similar solutions. I mean business logic. This kind of business logic is defined in the scope of the theory. It's named flowcharts. And it's flowcharts. It does have so basically recognize that logic implementation. Namely, this example, it shows decisions about changing the lamp, namely lamp bulb. We here do consider both ways. We have ways no and ways yes. And this very simple example, it shows us a very complicated routine. And maybe we can state that all our activities can be boiled down to such a routine. It namely would be clear or not exactly clear how to bring down a complicated business logic, subject domain, to such a simple construction. Why not? Because it's not easy. If it would be so easy, there would be no all this theory, all this DSS. We would have maybe multi-leveling flowcharts, and we will be able to work on one level, then jump to other level, and it would be the same. But in many sources we can read that all things in IT solutions is repeated from, say, one place to other place, just we can copy solution and copy solutions with one conditions and very easily to translate it to the other conditions. Generally, it's not true. It's not true because that will be linear. No, DSS is not linear. It's far not linear because DSS is much more complicated ways of finding the solutions. And why we are having such complications. In our case, our general case is energetics, yes, namely intelligible decision support system in energy sector. It's when we plan to create such new MSc program, it was provided, it was expected that exactly this application in energetics would be most needed for people, for ordinary people, for general society, and so on. Because energetic is the very basement of all we can construct, all we can develop in our life, and is the economically all economical rules, and some tasks that are much simple or much complicated, more complicated, and extremely complicated. The truth is that most of the real life task, is very extremely complicated. And to say that in any application we can just so simple draw these arrows from one thing of stuff to other, maybe from one object to other objects. Yes, can be before some implementation, and any implementation includes some action. In this case, we have two simple actions: plug in lamp, replace bulb. So the question is, lamp unplug it, lamp plug it in. So your answer is no, it's logically. And in many other cases, we would have not a simple arrow. It would be a set of arrows. So next important things in DSS is DSS arrows. DSS arrows, it shows to us some way of decision making. It's namely says what decision we gonna make. If we are talking about pure virtual surroundings, that is most easiest case, because in these surroundings we would have possible complication in very exactly to put these arrows. It's open secret that mostly all application is object oriented. So we what it means objects oriented. It means that we do have to deal with more preferably with objects than other construction. It's like some new way in maybe simple stuff, maybe not. It depends from the kind of data. So in our introduction, I singled out a very important problem at data. A data for this DSS basement. SOV is new, very important conceptions is DSS data. It's easy to say, but it's not easy to get. I mean that conceptions like DSS subject domain, DSS data, that's all is expected. We can expect or not expect. They are explored, not explored, maybe in some complicated state, maybe in some explicit representation, implicit representation. Here we can have a lot of possibly ways, possibly variants for using one or other ways for application, for building an application. So when we talking about DSS, we need all these stipulation put in our solution. Let us slightly review the situation with clearly defined routines for information exchange. So DSS implementation firstly is about information exchange, or it's a much closer topic is data exchange. It means that one objects are sending data to other objects, and this object accepts data, verify data, or maybe rejects data because of its kind of inconsistent data or spoiled data or maybe precise data, and the worst case is simply fuzzy data. Yes, it's in IT in generally, in DSS, we build some scenarios, build some strategies of implementation. In the case of this light lamp bulb, is very simple strategy. We have to check is there a lamp plugged in, or maybe it's burned out. So we have take two simple decisions by visually check. What we can say about this slide? It's simple case, very simple case, but it's very deep sample for understanding all the things that what is DSS about? What is DSS about? It's about on evaluation based on data sample. So next stage, next conception is a data sample. That means we have a data, we say about some very general data. Maybe somewhere we have this data. Mostly in IT solutions we use just simple way like data grid, data source, data grid, data source, data set. Data source, data set. So kind of three components, triple constructions. And in newest application is the role of data roles of data source is some native clouds, data clouds, and if we getting under hood of this construction, that must be defined a data source for this way. So we cannot state that all this data source is so very we don't know about this data surrounds. It must be clearly defined data source. And in this data source we have data set, and again data sets is things that we use to operate the data. I mean elements of data. So that is solution about two cases. In real life, we would have much complicated cases. But here is like we generally talking about just data and big data. We all know that it's not question of quantity. I mean that a lot of data is not meaning that it have features of big data, because it's newly defined data and features. It's the features. So in the terms of application, here we have things that would clearly define it in the DSS DSS conceptions. If you're talking about the question of implementation, then we have to put it in one row. Many checking out. So before preparing a decision, its meaning of it is that this decision would need to have clearly defined rules or ways for data exchange. That was above, yeah. And here in the lab 1, you can develop some strategy with some number of conditions, some number of action, and this would it should be working, because it's because business logic of such a solution is very close to the native programming logic. And all that is close to native logic, it's providing a very efficient result. In terms of application to that constitutes many other application to follow this sample. Many students say that that lab 1 is just case of linear application. It's not, because you have to check many conditions. And these conditions can be nested. Nested checkout. It's like one condition is inside a scope of others. So DSS in general, yeah, it's very related to scope division. Scope division of all the area that we have to explore. What I mean? I mean that if we say that we projected some DSS for subject area, we cannot state that it uses all the data inside this area. We can say only that it uses some part of data, and it not because we didn't did something wrong, or we was in no condition to do it, because there is maybe no sample at all for area of application or subject domain that is 100% explored. 100%. It's not possible because of few reasons. First one is that in real life we mostly are working with strongly dynamic subject domains, not static, and this dynamic is very high. It means that in this area there are constantly generating new data, and this data is that is just one of the cases of the sources for big data, yeah, in new conditions, in the area, in the time we live in, is a time of cloud-based data, Internet of Things, all this in time of social messengers, social communication based on computer network. All this is supposed to generate data, and this data is constantly rising for very, very, very great amounts, And general rules is, in this case, is that the more we have applicable data, the more we can state that we build an efficiently useful application for highly defined demand of it. It's DSS. We cannot test this system in the way we do it with other more simple application. So this is our first lecture. We discussed the general problem of DSS, and in the following lab we just stay connected, stay wired. I gonna type more information about first lab, and you starting to some coding on the tool you would take as preferable, and all this preference would help you for building a more quick solution.